হ্যালো স্যার, আসসালামু আলাইকুম। স্যার, আসসালামু আলাইকুম।
Assalamu alaikum and good morning, everyone. Let us wait for 3 more minutes before we begin. And also one more thing, since today is the last class before meet, so at the end, if I forget, please remind me. I'll just talk about like how the meet exam will take place, like how the questions will be set and things like that. So if I forget, remind me about that. Other than that, today's class should not take much time. It's also small, like the previous one. And of course, the syllabus is what I cover up to today, including today's topics. That means up to lecture 7, including arrays, all the things that I have taught, and also whatever Boktiar sir has taught before me is also included in the syllabus, all those things. And you have access to all the necessary files, slides, books, everything in the material sections of your theory classroom. Okay, well, everyone arrives. Let me just start the presentation and start recording. Is my screen visible?
Yes, sir.
Yes, sir.
Okay, so let us begin our today's class. Again, before going into the review of the previous class or beginning today's class, I will ask all of you the same question again, like the previous class. So, what are the basic control constructs or control structures in a structured programming language? Anyone?
Sir, these are statement, selection, iteration, and recursion.
Yes. So, by statement, we mean sequential execution of statements, that statements will be executed one after one. Then we have selection, that means condition-based execution of statement like if or the conditional or ternary operator. And then we have iteration or looping, for loop, while loop, do while loop. And then we have something called recursion, which we will cover later. These are the control structures. Other than that, we also have two other things. One thing is called subroutines, and the another thing is known as blocks. So we will discuss about them later. So before beginning the topics of today's class, let us quickly review what we have covered in the previous class. So we were talking about arrays. Now, we know that basically arrays are nothing but a sequence of objects that are generally of the same type, and they're stored in a contiguous area of the memory. Now, this is how we declare an array in C: type, identifier, and then inside square brackets, we declare the length of the array. For now, we know that this needs to be a constant expression, but we'll take a look at something else at the end of today's class. Then we were mainly confined to the description of one-dimensional arrays in C because that's the mostly used thing, and we can consider them as a list or row or a column, whichever flows your boat. It's like a list of a blank list. We think of them as a blank list where we can actually put our own data, and we can treat each of the elements of an array like an individual variable. Okay. And also macros are good. Preprocessor macro constants are a good way to define the length of the array as constants, so that we can use them to manipulate the array later on using loops and other things. Then we have access to each of the elements of an array using the subscript or indexing operator. We have seen some examples. We have seen how for loops go hand in hand with arrays to maybe declare the values, change them, scan them, print them, increment, decrement them, sum them up, or whatever. And one more thing, one important thing that we have noticed, unlike some managed languages or high-level languages, C actually does not require bound checking. That means whenever you are accessing an array, C by itself will not check whether you are violating the index that you have allocated or not, and it will result in an undefined behavior depending on the compiler, maybe on the operating system. So you manually need to be careful as the programmer. We know that they can be integer expression, the subscript operators, and we know we should avoid things with undefined variable, which is caused by the anonymity or of sub-expression evaluation. And we have seen one example where we used an array to reverse a series of 10 numbers. And we have seen different kind of initializers, the normal ones using list. And then we have seen designated initializers in case of C99 or above, where we can define the values of only some specific elements where rest are set as 0. And if the length is omitted, the highest designated initializer is used to determine the length of the array. And then we have seen another example to count repeated digits, or basically to detect repeated digits. And then we have seen how we can use size of operator in case of array to determine the number of elements inside an array dynamically, which will come handy into this class at the end maybe. But whenever you move on and do even more complex things and deal with something called dynamic memory allocation or dynamic arrays, then these things will be really helpful. And I've also shown you another example and asked you to try it out, where you need to use an array to do this calculation. Okay. Anyways, now on to today's class. In the previous class, we talked about one-dimensional arrays. Now we will move on to multi-dimensional arrays. And as the name suggests, there are more than one dimension in these arrays. Now, I've already told you that one-dimensional arrays are like columns or rows or leaves, whichever you prefer. And whenever we move on, generally, like in case of one-dimensional, it is like a line. In case of two-dimensional, even in mathematics, it is like a surface. In three-dimensional, it's like any object in our real world, like maybe a cube or sphere or any other object we see in our real life. All those things are three-dimensional objects. And whenever we move on to even higher dimension, up to a certain point, maybe we can visualize a part of it or maybe a shadow or projection of it. But when we move on even further, it becomes difficult for us to visualize those things and they become pure mathematical descriptions. But we know how to do the mathematics with them and how to handle them. So multidimensional arrays are kind of like this. Like if you think of a one-dimensional array like a list, you could consider a multidimensional array as a grid. And then maybe a two-dimensional array as a grid, and a three-dimensional array, maybe a cuboid structure, one structure like a cube, and we'll move on. Declaring a multi-dimensional array in C is simple, just like a single-dimensional array. First, we'll have the type, maybe integer, double, or whatever type. Then we have the identifier of that array, any valid identifier in C. Then we'll have couple of curly brackets or curly bracket pairs, and that number will be equal to the number of dimensions we want to have. So if you want to have n dimensions, we'll have if you want to have n dimensions, we'll have n bracket pairs. If you want to have 2, we'll have 2 bracket pairs, 2 bracket pairs. And if you want to have 3 bracket pairs, and so on. And inside each of the brackets or bracket pairs, we will define the length of the array of that dimension. So let us visualize this using an example, a very common one. We know that if we have a two-dimensional grid of numbers, we can consider it as a matrix, a very common example. So if we have a 3x4 matrix, where 3 is the number of rows and 4 is the number of columns, in C, we can declare them as an array like this: integer, then an identifier, mat, then first the number of rows and then the number of columns. So this is how we can visualize it. Remember one thing, arrays in C are row major. That means the first thing that you have are actually row, and then you have columns. In case of higher dimensional, we do not attach names like rows or columns, but one thing, maybe I'll get it to you after this slide. So this is how we can visualize a matrix in C, a two-dimensional array. The number of rows are 3 3, and the number of columns are 4. And again, all of them starts with index 0. So whenever we want to access them using subscript, we'll use 2 brackets, 2 square braces, because it is 2-dimensional, and first value will be of row and the second value will be of column. So these are the subscripts for each of these slots in the array here: 0001, 0203. And if in case of row number 3, 2021, 2223. Okay, so if you want to access the jth column of the ith row, then we'll write mat I j. Ith column, ith row, jth column. First one is row, second one is column. So one thing, though we have like 2, 3, or even more dimensional arrays in C, they are basically logical. That means we visualize or we think them or we access them as multidimensional array. However, when we are actually storing them in our memory, we are storing them as a flat one-dimensional array. And I've already said they are stored in row major order in C. That means each of the rows are cut and then pasted one after another, making it a flat one-dimensional array. So first row, second row, third row. If we want to see here, this is the first row, then second row, then third row with index 0, 1, 2. And so we have 0, 0, 0, 1, 0, 2. Then we have the index 0, 3. Then we have for the second row, we have 1, 0, 1, 1, 1, 2, 1, 3. And then we have the third row, one after another in a one single line. That's how multidimensional arrays are actually stored in memory in language C. One more thing, it is very important, like in some languages this is valid, but we know that we cannot, if we want to access the jth column of ith row, we cannot write it as mi comma j. We need to write it using 2 separate square brackets, because comma in C is an operator, and I comma j will be evaluated as just j, because comma takes the just returns the last operand value as its operation result. So do not make mistakes like this. If you want to access the ith row's jth column, don't write I comma j. Instead, write I and then j inside 2 separate square braces. Pay attention to this, like I comma j is equivalent to mj. And if you want to visualize using a color, these are the different rows. They're colored differently, and whenever you are ordering, storing them in row major order, basically the first row, then the second row, then third row in a single flat line. Okay, so again, just like normal for loops go hand in hand with one-dimensional array, we can use nested for loops to process multi-dimensional arrays. Like if we want to create an identity matrix, by the way, if you have forgotten what is an identity matrix, generally an identity matrix is a square matrix. Forget about the final column. Let's say we have only 3 columns and 3 rows. In that case, identity matrix will have one's value 1 only in the principal diagonal at all the places, and rest of the values will be all zeros. So only the principal diagonal will hold the value 1, and the rest of the positions will hold the value 0. That's what an identity matrix is. And if we want to create a 10 by 10 identity matrix, here we have declared the array. We have used 2 variables, row and col, to control row and column. Then we are iterating through them. And since we know in case of row major ordering, columns change faster than row. That means if you have multiple dimensionals, the last whenever we're iterating through them, the last dimension will change the fastest, and then the one before that, and then the one before that, and the dimension at the leftmost will change the slowest based on how it is stored in the memory if you want to access it in that order. Now, we will use 2 for loops. In the inner loop, we'll iterate through the columns, and in the outer loop, we will iterate through the rows. And whenever row is equal to columns, that means if you take a look at the principal diagonal, the row values and the column values are equal, 0, 0, 1, 1, 2, 2. Only then we're setting those values as 1, and in rest of the cases, we're setting it as 0. And afterwards, we'll have our 10 by 10 identity matrix. So before going into the initialization of multidimensional array, does any one of you have any question regarding the things that I have said so far? Okay, So it seems like you didn't, none of you have any question. So I will move on. We have seen the one-dimensional initializers for one-dimensional array. Now, in case of multi-dimensional arrays, we can basically nest one-dimensional initializers inside another initializer to make it a two-dimensional initializers. And again, we'll provide them row by row because C is row mature. So if we have, let's say, an array of the dimension 2 by 3, 2 rows and 3 columns, we can define the initializer as first row and the second row. And it will exactly look like this. Like the first row will hold the values 1, 1, 1, and the second row will hold the value 0, 1, 0. Now, in case of one-dimensional arrays, we know that if we leave any values unfilled and we use an initializer, they will automatically be set to 0. And the same holds for two-dimensional initializers. Like this is a 5 by 6 array, 5 rows, 6 columns. In the very first row, we have provided all the 6 values. So the first row will hold all ones. In case of second row, we have provided only 4 values. So the last 2 values will automatically be set to 0. In case of the third row, we have provided 5 values and 1 value is missing. That value will be set to 0. Fourth row is exactly like the second row. 2 more zeros will be added at last. And then an entire row is actually missing. We haven't provided any value for that row. And all the 6 values of that row will automatically be set to 0. So if we want to visualize it, it's basically like this will be the outcome if we just initialize with that. So the previous one that we initially provided, this one is exactly equivalent to this one. The compiler will fill the rest of the values.
Sir, I have a question.
Yes, go on.
So if we don't initialize an array, just like declare the size of the array and then try to print the array, will it print garbage values or will it print zeros?
Garbage values. Depends. If you declare the array inside your main function, which you generally do, in that case, it will print garbage values. However, if you declare it as a global variable, it will most likely print value 0.
Okay, thank you.
Global variables are initialized as zeros automatically. I will not explain how they are done because that's part of another course, like processor assembly and maybe compiler design. And there are different sections in memory where things are allocated. So wherever this thing is stored, global variables are not stored there. They're stored at different places. That's why they are automatically initialized with the value 0. Anyways, so for now, for the simplicity, since we're declaring everything inside main function till now, just know that if we declare a blank array, just like a newly created variable, normal variable, scalar variable without initializer will give you any garbage value, arrays will do the same. Okay. Now, one more thing. We actually do not need to provide like a two-dimensional initializer. We can provide a one-dimensional initializer directly. Let me give you a simple example. Let's say we have a 3 by 3 array. I might call it matrix. In some cases, it's fine. It's all the same. Now we know that in a 3 by 3 array, there will be 9 values. So if we want to initialize an identity 3 by 3 identity matrix, we can write it like this as well. Since there are 9 values, the compiler will automatically understand, okay, so let us start filling them one by one. And the compiler will go on and start filling row by row. So the first row, since there are 3 rows, 3 columns, the first row will have 3 values, like 3 column values. So this will become the first row, this will become the second row, and this will automatically become the third row. The compiler will automatically does it for us. And if we leave out any value, like this, if you only fill like 7 values, the compiler knows it will need 2 more values, so it will automatically fill those with 2. two zeros, sorry, with two zeros. Automatically fill those with two zeros. So that's how the compiler will work. However, it's a bit risky. Why? Like whenever we are working with a two-dimensional initializer for a two-dimensional array, what we could do, like if you want to keep any of the rows unfilled, we could have kept them unfilled, and the compiler will go on and specifically fill that row with zeros. Like in this case, if we want 3 rows, so what we can do, like maybe if we want to fill a matrix where all the left columns are 1 and all the left columns are 1 and all the right columns are 0. So we could have written something like this, and the compiler will automatically expand it to be like this. Fill the rows automatically with zeros. However, had we used a flat one-dimensional initializer without the second dimension in it, like one, we remember we are not only filling the values of the first row, and then rest of the 2 rows are filled with just all zeros. So based on how you actually want to initialize, be careful. If you like need a specific values for each of the rows and you want to leave out some values for each of the rows individually, then use a nested two-dimensional initializer. And again, just like we have designated initializer in one-dimensional array from C99, we also have them for 2 or higher dimensions. We just need to mention its subscript or its element position inside the curly brace, and then we can just write their values, and rest of the values will automatically be filled with 0. So this will initialize a 2 by 2 identity matrix automatically, and the position 0, 1 and 1, 0 will automatically be filled with 0 value. So they work with it as well. So before going into constant array, I have shown you like one-dimensional array, two-dimensional array. But if you want, we can also have 3-dimensional arrays or even more. And you can visualize 3-dimensional arrays as a cube, like maybe 2 by 3 by 3. So instead, we can still call them row and column, but that doesn't make any sense. So if we think it maybe like a cuboid structure, we can call it maybe height, width, and depth. So this is height, this is width, and this is depth. So height is 2, width is 3, and depth is another 3. And we can also declare them using initializers directly. So what we can do, first of all, we know that there are 2 rows. That's clear to us. So these are there are like height-wise 2 elements. So these are the 2 elements of the heights. And then we know in each of the elements, there are 3 more things or 3 more widths. So these are all those 3s. And you know, inside each of these 3 things, we also have 3 more values. So maybe 1, 2, 3. 5, 6, 7, 8, 9, 10, 11, 12. 17, 18. So we should have in total 2 into 3 into 3. That means 3 into 3, 9, and then 2, 18 values. And these are those 18 values that you need. 3, 3, 3, 9, and then 92 is 18. So that's how you can see a 3-dimensional array. So generally, whenever we are at like a very high dimension, like 3 or more, we do not generally write initializers directly like this because they become a bit difficult. Yeah, even up to like 3 dimension, we in some cases directly write the initializers, but afterwards, you know, they are like based on some relationship, they are basically generated or maybe read from some other dimensional values and then merged together to take it to a higher dimension and so on. Like you can think of a cube as a slice of like maybe if you think of a Rubik's cube, people might have seen those cubes where you need to match the colors. There should, like if you think of it as a cuboid structure, a cube, there are like 27 small cubes, 27 elements. So you can basically slice it into 3 different sheets where each of the sheets will contain 9 elements. You can read it like that and then merge them together to make it a cube. Okay. So that's how.
Sir, I have a question.
Yes, go on.
Sir, why you are using 1.0 instead of 1 in the slide, sir?
Here, 1.0,
Yes, sir, this one.
because the type is double. I could have also write 1. In that case, that 1 will be considered as an integer, and then the compiler will convert it to a double value and then store it. But since I know like it is a double matrix, like the type is double, so it is a floating point value. That's why I'm directly providing 1.0. Like if even if a programmer doesn't pay attention to this type double and quickly reads it, he or she knows that the identifier is called identity is 2 by 2, and whenever he or she sees that the value is 1.0, he or she will definitely know, okay, it is of double type. That's why I have written 1.0, because whether I store 1 or whatever it is being stored as 1.0. Okay.
Yes, sir, thank you.
Okay. So any more questions from yes?
Sir, in for example, n by n matrix, if you want to fill the first row on only the last row and keep remaining zeros, how do you do that?
Okay, so if you want to fill if you have maybe a 5 by 5 matrix, right? 5 by 5 matrix, and you want to fill the first rows with some values and last rows with some values, right? And keep remaining. So there are a couple of ways. Maybe I'll provide 1, 2, 3, 4, 5 for the first row. Okay. So in the second row, we cannot keep a list empty. So we need to provide 1 values, and rest of them will automatically be filled with some value. So second, third, fourth, we'll just give them zeros. So we know they will be expanded to 0. And for the final row, we can provide whatever values we want. Maybe again 1, 2, 3, 4, 5. So this will automatically make your matrix for you. Got it? Okay. So did you people understand the concept of 3-dimensional matrix as well, or like 3-dimensional arrays as well? Because if you haven't, I might show you something. So have you can you visualize a 3-dimensional array, or should I show you something?
Show us
Yes,
something.
better show us something.
Not for this application to put up. Let's say we want to visualize this thing, like where there are 2 rows, 3 columns, and depth-wise it is also 3. Right? Let's say we want to visualize this thing. There are height-wise 2 elements. There are height-wise 2 elements, width-wise 3 elements, and then depth-wise 3 elements. So we can visualize it like this. And what was the dimension again? 2, 3, and 3. So it's a bit finicky. Anyways, so it's a 2 by 3 by 3 array, right? So there are 2 rows, 3 columns, and then depth-wise 3 values as well. Now, if we take a look at this, these are the 2 rows, and then we have 3 columns, 1, 2, 3. Okay, consider it. Sorry, my middle mouse is a bit finicky. Middle mouse click. Sorry. So there you go. If you consider this is the front, wherever I'm pointing the mouse at. So these are the 2 rows. These are the 3 columns, first column, and then second column, and then you also have the third column, and then we also have depth-wise 3 values. So these are the depth-wise 3 values. Depth-wise 3 values. Now, if you want to go one by one, how the matrix will be iterated, or how the array will be iterated. So first, we know that we go column by first we go depth by depth, because that's the last dimension. The last one is depth, and that one will end first. So first row, first column, this is the first element, second element, third element. Move to the next column. First element, second element, third element, fourth, basically fourth, fifth, sixth, seventh, eighth, ninth element. Now we'll change the row. 10th, 11th, 12th element, 13th, 14th, 15th element, and then 16th, 17th, and 18th element. So this is basically this exact array M. And these are the values 1, 2, 3, 4, 5, 6, 7, 8, 9. Like 1, 2, 3, 4, 5, 6, 7, 8, 9. That is how the array is like we are how we are visualizing the array. So this is the cuboid structure that is the representative of the array. Did you people get it?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Any question? In that case, we can move on to the next topic, which is called constant arrays. So I have already showed you, or I have already told you in the very first class where we are talking about constants like precursor constants or compiler constants, that we can attach the keyword, basically a modifier keyword, const, with any data or any variable that we have. And basically it makes that variable read-only, meaning that we can declare and initialize it once, but once we have already initialized it, we cannot modify the values anymore. Like if I have an array like this, const hexchars, basically it signifies or it stores all the characters that represent a hexadecimal number, all the valid values or digits of hexadecimal number inside this array. And if we declare them as a constant, if we try to modify them later on in our code, like equal to maybe say give us an error and say that it is not a modifiable L value. Basically, this is a read-only value which we cannot modify later on. So we can also declare arrays as constant. And remember, whenever we are declaring a constant array, we should initialize the value right away, right there, because we cannot modify it later on. And again, we can leave the size empty and the compiler will deduce it automatically. So there are a couple of advantages. Basically, it documents that the program will not change the array. Whenever multiple people are working on a single program, we'll be using definitely in most cases, using multiple files. So generally people only know about the identifier unless they go and check it themselves. And if they somehow mistakenly tries to change the value, the program will not allow the programmer to change it and it will give the error. So the compiler can also catch the error that it is not modifiable. Yes?
So instead of specifying the values for the array, can we actually take input of the array?
No, you can't.
Scan function.
If you want to use a scan function, then is the array constant?
So just the first time, can we do that?
No.
Yes, sir.
You can't do that. Okay. Otherwise, it completely breaks the concept of constant. There are ways, like there are tricks which might be used, but don't do that. Actually, changes the meaning of constant. And again, like one small notation, you do not need to remember that. Though we are saying it like this is constant, right? Constant integer val is equal to 10. So like I cannot write c val is equal to 11 anymore. But there are also ways to actually change constant values in C. That's basically one kind of cheating, because that's why in most cases we say that whenever we declare something as constant, it is a promise. It is a promise between the programmer and the compiler that it will not change. And just like any promise, and we're human beings, we can break it. So it's just a promise where the compiler will actually help us to let us know that this shouldn't be changed. But still, there are tricks using which we can change the value, but we shouldn't. So that's why this type of constants are not like truly constants. And whenever you move on to other language, like maybe C++, then you have something called constant expression. And if you're using constant expressions are not changeable. Those things are actual like constant, compiler constants. You don't need to remember these two things anyways. So this is one problem. If I believe if you people try and can do this problem yourself, this is like a really good practice. And once you can do this, you can build any basic simple command line application with C. So let's discuss about the problem. Let's partially discuss about the solution, and I want you people to find out the solution to it yourself. Practice it, keep it as the final practice before the mid exam. So I hope you people are familiar with playing cards. If people are not, I would like you to Google what playing cards are. So basically in playing cards, we have 52 cards. You have seen it. You might have, most of you should have seen it. So we have 52 cards, and they are divided into 4 different suits. There are 4 different symbols. The suits are clubs, which look like a kind of like a tree and have black color. We have diamonds, which look like a square diamond and have the color red. We have hearts, which have the symbol of hearts and has color red. And then there's spades, which look like a leaf and has the color black. And then in each of the suits, we have 13 cards. The cards start from 2, 3, 4, 5, 6, 7, 8, 9, and 10. These are numerical cards. And then we have something called face cards, where we have Jack, Queen, Key, and then an Ace card. So these are the 13 cards. For now, just remember them by name. These are the things. And if you have any problem, related to these things, the suit and rank will definitely be provided to you. So these are 13 into 4, 52 cards. Now, your job is to take an input from the user. How many cards he or she wants to be dealt with. So if the user enters 5, you need to serve him or her 5 random cards without repetition. In this case, 7 of clubs, 2 of spades, 5 of diamond, ace of spades, and 2 of hearts. So there are 2 problems you need to solve. First of all, you need to randomly pick a card from the deck. And second, you need to make sure that you are not picking the same card twice. There are a lot of ways to solve it. If you take a look at the book gives you one of the solutions. This problem is there in the book, exact problem. You can take a look there if you want to solve it, but first I want to try it yourself. So I will give you a hint about each of these problems. First, randomly pick a card from the deck. Some of you might have already encountered the rand function in C. So again, I'll show you to all of you. Before showing you how you can choose random card, let's see where we can use array. Let's say for each of the suit and each of the deck, we can declare a character array. Maybe character suit, and we can declare him there's spade, there's diamond, there's hearts, and there's blocks. So we can declare the suit like this as an array. We'll pick a value from this maybe. And then we have maybe the ranks. So we can declare them as rank like this, array. And we can initialize it maybe character 2, and then 3, and then we'll go on and we'll go maybe up to 9, because there are 9 these are the numerical cards. And then we have Jack, and then we have Queen. Maybe we can use small case letters for the ranks, so that doesn't mess up. We have the King, and then we have Ace. So we can declare the ranks like this. You need to fill this up. This is not a valid thing. I'll just skip some parts of it. So you can declare the ranks like this. And afterwards, what we basically need to do, choose a random suit, choose a random rank. Alternatively, you can craft a third array, which have maybe 52 values from the suit and ranks array, and store the values there. So using that, you can trace back to these arrays if you want. You need to map it, how that thing is being blended with this one. Now, how do we choose a value from the random array? So this is how you can declare the suits and ranks. But for the simplicity, let's say we have only one array, maybe with 5 cards. And the cards, and I'll also make it an integer array. So the values there are 1, 2, 3, 4, 5, 6, 7, 8. Okay. And we need to randomly pick n values from this array, where n is less than the length of this array, and the user will provide the value n. What can we do? So basically, the random function consists of 2 function calls. The first one is generally like this. or you can also see null. Both are same. Null means 0. You see. And then if you want to have the index, maybe random index is equal to rand, and then modulo. There are like 10 elements, so modulo 10. Let's see what is happening in place of random numbers. Remember, computers can never generate random numbers. There is no such thing as true random numbers in computers. Since it's a machine, it works based on program, and there's no such thing as random in program. Okay, so whatever like we get from computers, which is like random like, those are called pseudo random numbers, where the word pseudo random number. By the word pseudo means fake. So the random numbers we get inside a computer are fake. So I'll give you a very dummy and lame example of maybe how we can generate a random number using a mathematical equation. The actual equations are far more complex, far more bulletproof, and they work really well. But I'm giving a simple dummy example. Let's consider a mathematical equation like this. Here, this equation can actually generate some numbers between 0 to 10. Again, why can this equation generate only numbers between 0 to 10? Because we're taking the remainder with respect to 11 at the very end, and we know whenever we take a remainder with respect to any number, the possible values are from 0 up to 1 less than that number. So the values will be 0 to 11, 0 to 10, because if it is 11, it can be divided by 11, and so the remainder will become 0. And let us begin with an initial value. So can anyone give me a small initial value for x? Anyone?
One.
1.
1 or 4, which one?
70.
Small value. Like I do not want to do a lot of calculation right now. Sorry.
10 is the value.
Okay, I'll go with the initial. Someone says 4, I'll go with 4. Let's say initially x is 4. Okay. So what will be the value of this equation? 4 into 7 is 28. 28 modulo 11 is 6, right?
Yes, sir.
So if this is the value, let's say we get the value 6 afterwards. After one run, we get the value 6 as x. Again, if we plug 6 into this equation, what will be the next value? 9, right? Because 6 into 7 is 42, and 42 modulo 11, 42 minus 33, that is 9, right?
Yes, sir.
Now we
Yes,
get
sir.
the value 9. Now if you plug the value 9 again in that equation, 9 to 7 is 63, and 63 modulo 11 is 8.
8.
Right? So you see, like if we just didn't know the first initial value, like if it was kept hidden for us, but it was 4. So first this equation is giving us 4, then this equation is giving us 6, then it is giving us 9, it is giving us 8, as if the value is randomly changing between 0 to 10, right?
Yes, sir.
Okay, so that's how random numbers are produced. Like in case of this rand percentage 10, now if we again give percentage 10 with respect to this one again, afterwards, the value will be kept between 0 to 9. Okay, sorry. My electricity just went away. Am I audible again? And is my screen visible?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Okay, sorry. So, like if we take again the modulo with respect to 10, we know now the value will be kept between 0 to 9. That are these index numbers. So this is the equation it apparently like it just looks to us like these values are random, changing randomly, though these values are not actually truly random. So that's
Sir,
what.
how is the program or the function choosing x? I mean, that is also random.
I will tell that one. Like for now, the function rand, let's say it has one initial value. It has some initial value, some fixed value, initial fixed value. And it is passing it through a complex equation, far more complex equation than this. And it is giving us the random values one after another for each different call of rand. And then we're taking it modulo respect to 10, and we're getting the value 0 to 9. Up to this part, it is clear, right?
Yes, sir.
Okay, so now comes the question, how can we set the very initial value? This value, the very first value of x, this is called the seed of the random number, because this is what starts the whole random system. And on this very first value, the whole random system depends on. And this is where we set the seed. S of rand, we have set it equal to time of 0. Basically, time of 0 sets the seed of the random number to be your current time, maybe up to microsecond, millisecond, those things, millisecond, microseconds. So what happens whenever you run the program every time based on that execution time, the seed changes. Makes sense?
Yes, sir.
And if you trace the execution time very granularly, maybe from the very beginning of time, how computers calculate time is basically there is something called an epoch from wherever like calculation of time starts. For simplicity, like in case of like Gregorian calendar, you can think of like the 000, the year 000 and the time 000 in 24-hour format as the beginning of time. And from there, you can calculate how many milliseconds or how many seconds have actually passed or microseconds have passed. You can think of, for simplicity, you can think of it that way. And then we can plug in that value inside as the seed of the random number. So each time whenever you're starting the program up to like maybe millisecond, microsecond, the value will definitely change. The value will definitely change. And as a result, each time you run the program, it will seem to you like you're getting different random numbers.
So it is a real-time value, right?
It doesn't. Whenever you call the time 0, it gives you the exact time value of that time whenever you have called from the operating system.
Okay.
But it doesn't keep on changing. Like if you store it in a variable, whenever it is being stored, it will fetch the value of that exact time. Afterwards, like it will not change anymore. If you call time again, then the value will change. Right? Whenever you make that call, it will fetch that exact time. Okay? From the operating system.
Thank you.
So based on that, the value of the random number are being changed. It seems like a random, but then again, it's not a true random number. Now, we have solved the first problem, right? That is randomly picking a card from the deck. Like if we get a random index and choose a position from that, now we know the random number, like we know the index, right? If this returns to us 8, we can go to the 8th position. And this will be our value. Like 8 means 9th position. We can go to the 9th position and this will like give us our value. So it's fine. How do we avoid picking up the same number again? There are multiple ways. Like if the array is really big, you can actually keep trace of which numbers have already been picked. And if that number is picked again, you can re-roll the randomizer. And whenever you get another value which has not been picked already, you can pick that one. Basically, you need to keep trace which number has been picked already. It's kind of like a bad solution. So let me give you another solution, another possible solution. Let's say first, from the randomizer, this value 7 is picked and you are showing it to the user. Now, what we can do, you know that the array has 10 values. So you can swap this current value with the very last value, like 10 and 7. Now, logically, you will consider the size of the array has decreased by 1. There will be 10 values, but next time, whenever you're running the randomizer, you will take the modulo with respect to 9. Now, only the values which will be picked are from 1 to 9, and this 7 will be avoided. Let's say 2 is picked. What we will do, you will show the value 2 to the user, and you will swap 2 with 9. So 2 is here, and 9 will come here. And again, now whenever next time you call the random again, you want to pick the random index again, you will take modulus with respect to 8, and now you're picking the values only between this one. So in this way, every time, whenever you're picking up from that array, you are discarding the parts that you do not need anymore. And maybe if 4 is picked next time, what you will do, you will swap 8 with 4 here. And you know that these are the values that have been picked by the user, and these are the values that have not been picked. So if you want to implement this one with like the cars, which is like have source and rank, you can craft another array, maybe from the number 0 to 51 or 1 to 52. And afterwards, you can determine which card represents which suit. Maybe from 0 to 13, it represents like the ranks of S. From like 14 to after next 13 values will represent hearts, the next certain values will represent clubs, the next certain values will represent diamonds, like this. So there are multiple ways to solve this one. So we have solved both the problems, right? Randomly picking a card from the deck and avoid picking the same card twice. Did you people understand?
Yes, sir.
Sir, can you please repeat the part? I mean, how can I avoid printing the same value?
Okay. Let's consider this one-dimensional array, right? We have this one-dimensional array of 10 values here. Okay. We'll pick a value from this array and show it to the user for the simplicity. And we have 10 values. So whenever we are calling the rand function, we'll take modulus with respect to 10, right? Initially.
Yes, sir.
Because it will give us any random value between 0 to 9, and we'll pick that index. So just give me any random number between 0 to 9.
Sir, 3.
3. So let's say we have got the index 3. So index 3 is the fourth element, right?
Yes, sir.
So this one has been picked by the random system, and we'll show it to the user. Let's say we're showing it to the user. And what we will do, we'll swap this value with the very last element of the array. So what was the very last element? 10, right? So we'll do the swapping of these two positions. We have already shown it to the user. So 10 will come here and 4 will go here, right?
Yes, sir.
Okay. We have already picked 4. Now logically, we'll decrease the size of the array by 1. By, let's say we are keeping a counter, what was the max length of the array? Now let's say like this one. And we are dividing it by. So what will happen next? We'll decrease array length by 1 after the user has shown something, and the array length will become 9, right? Then if you want to show the user the next card, now this is doing modulus with respect to 9, right? And the possible values are between 0 to 8. Are you with me?
Yes, sir.
Okay, so the possible values are between 0 to 8. Now tell me a value between 0 to 8.
So it can be 5.
It can be 5. Okay. So 1, 2, 3, 4, 5, 6. This is the sixth element, right? Because you have said 5. 5 is the sixth element.
Yes, sir.
Okay, we'll show 6 to the user and swap it with the element that's at the array length, our logical last element. So this is what the user has picked, or what the random system has picked for the user. We'll show it to the user and then swap it with the last element. So which one we will do the swap with? Can you tell me?
9.
Yes, 9.
9.
So 9 will come here, 6 will go there, and array length will decrease by 1. Right? Next time. And if the user wants another value again, now it will be rand modulus 8. The value will be between 0 to 7. You see, the values 0 to 7 are these values, the values that have not been picked yet. So did you get how the system is working?
Yes, sir. I got it.
Did you really get it, or just saying you have got it?
No, sir. I got it.
Okay, so in this way, it will continue. So if you want to do it for the cards, if you want to keep it simple, you can convert, like you can take an array between 0 to 51 or maybe 1 to 52, in total 52 elements. And from there, you can keep on picking like this. And after like you have the value, you can convert it to like a suit and card. Like you can consider the first 13 cards, 1 to 13 are of the suit spade. The next 13 cards are of the suit hearts. Next 13 cards are of the suits baby diamond. And next 13 are from the clubs, like 1 to 13, then 14 to 26 in this way. And you can convert that and you can print out the value. Got it?
Yes, sir.
Okay. So this covers like this problem. I would like all of you to try this one. This is for your own sake. This will be good for you if you try this one. So this is our last topic for today, which is called variable length arrays. Dihan, it will also answer your question from the previous class. Like array, that should be constant expression, but how can we scan the value from the user and it works, or how can we set it and it works. So basically after C99 and above, we have something called VLS, or variable length arrays, where we can basically take the length of the array as input, or we can keep it as a variable first and then declare the array. Like in case of this code, like integer mn, scanf mn to n, let's say the user enters 5, 3, what will happen? This array will have the dimension 5 by 3 in runtime first. But do not get confused. The size of the array, once it has been declared, will never change. Before the declaration of the array, we can take the size as input from the user. We can do some other calculations, maybe whatever we want. We can run some code, we can do some checks, whatever we want. We can do with the values, but once the array has been declared, like array 5 by 3, we cannot change the size anymore. And in this case, also these, like the values inside subscript can contain like expressions as well. Like if you want to declare one more, then like let's work with one dimensional array, like integer n, scanf %d, comma, and n, and then we can declare like integer r of maybe one more than that, n plus 1. Whatever the user enters, we will take one more than that. Now this is showing me an error because the parser that is showing me error in the real time is for C++, and it will tell me that it must be a constant value, but it doesn't need to be a constant value in case of C99 and above. And then we can do things like that. Maybe we can scan all the numbers from the user, like for integer I is equal to 0, I is less than n plus 1. Since we have taken one more, I plus plus. We can do scanf %d, comma, and array of I. And if maybe we want to print them in reverse, for integer I is equal to n, it will be 1 less than the total value. I is greater than equal to 0, I minus minus, printf %d space, comma, array of I. So now if we run this code, say it compiles just fine. Okay. And like maybe 2, and if you give the value 1, 2, 3, this gets printed in reverse. So the last problem that we solved, the problem we solved in the last class, like that requires you to like reverse 10 numbers. Now we have made it like variable. The user first enters how many numbers he or she wants to swap. Oh, sorry, he or she wants to have printed in reverse. Then we're using just declaring an array of that length and we're printing them in reverse. And I have just used like an expression here to show that the calculation inside that subscript for variable length array is also possible. So that's how it works. So after discussing the advantages and disadvantages, I'm going to rant for like 5 minutes why this thing is bad. You do not need to like memorize those things, but you need to hear those because this is actually a bad thing. Variable length arrays are bad in C. So first of all, what are the advantages of using variable length arrays? It reduces wastage of memory because we are declaring an array with the length, just the length. I don't know, it average program failure. Maybe like you had declared an array of 10 values and the user wants like 11 values. The user is entering 10 values and the program is crashing. Maybe that's why it average program failure. What are the disadvantages? It cannot have static storage. Just like read this line. I'm not going to discuss static storage because that's not part of this course. That's part of compiler design. So it cannot have static storage, and you cannot write initializers for the variable length array. Definitely because you do not know the length of the array, length of the variable length array, so you cannot write the initializer. However, if maybe you are initializing an array, a blank array, using maybe a C99 stack designated initializer, and you scan the value, like maybe something like this, int air equal to n is equal to maybe 10. So if you're using designated initializers like this and you take the value as input from the user, in that case, you can make it variable length using that designated initializer by scanning the value of n from the user. But you cannot do things like that, like where you declare the length of the array using a variable length taken as input from the user, and then you want to just initialize with 1 to 3. You cannot do this one. This one is not allowed. This one might be allowed. I haven't tested it. This one might be allowed, just like Dhyan said, maybe. Dhyan, is this one allowed?
No, sir.
Okay, this one may be allowed, may not be allowed. Right? Let's try to like check what happens. See whether it compiles or not. Okay, yeah, this one is not also allowed. So only like this one is allowed using variable. Okay, so initializers are not allowed at all. Only this one is allowed as the initializer, no kind of like as the declaration of variable length array. Only this thing is allowed. You cannot use any kind of initializer with the variable length array. This is a major cause of stack overflow. I'll discuss it in like briefly. And variable length arrays are not part of standard C++, and they are not available in that language or many other languages due to obvious necessary reasons. Let me tell you why. In short, you don't need to remember, just hear me out why these things are bad, why variable length arrays are bad. So whenever you're declaring a variable like this one, these things are called stack allocated variables. Whenever a program is stored in your memory of your computer, like the RAM, the program is divided, the variables that you use inside that program are divided into different sections of the memory and put there. Whatever you declare like this inside your main program, declare in this way, are stored in the stack. Now, though a program can use up all the memory of your RAM, like if your RAM is 16 GB, a program can almost consume like 16 GB as well. However, it cannot consume those 16 GB from stack. The stack memory is basically there for the management of the program, and it is limited. Like by default, in like most modern PCs, your stack memory is like 1 megabyte. And we do not want to dynamically change the amount of storage or amount of memory that is consumed from the stack. We want to know almost the amount during the compilation time. So two major things which can actually violate, like the other major thing which can violate the memory of your stack is using recursion that can run out of stack. And the other thing, another thing is like this one, because you do not know what the value of n will be when the user enters. And if the user enters a huge number of n, which will require more than 1 megabyte of memory, whenever the program tries to declare this amount of memory in the stack, it will cause a stack overflow error and the program will crash. But you have like a huge memory in your computer, 16 gigabytes of RAM, and your program needs just more than 1 megabyte, but it is crashing. It is crashing. That's not expected. So in these cases, where you require an unknown amount of memory and you want to like declare an array very tightly bounded with that amount, you can use, the best practice would be to use something called dynamic memory allocation, which we will discuss after meet. Okay, it's like one of the last topics, or it's a bit difficult after pointers. Dynamic memory allocation will come. We can use something called dynamic memory allocation to stack that amount of memory in the heap instead of stack, and that will not cause any error or any problem. Okay, you can even consume like 8, 9, 10 gigabytes of memory from RAM in that way if the operating system permits it. So that's why, like, one more thing, like the father of C++, the person who invented it, his name is Von Stroustrup. So whenever, like, I think whenever like this VLA was introduced in C99 as a part of standard, he said that it is a misstep the standard of C, because this can be a source of a lot of problems. And you know that there are different operating systems like Windows, Linux, Mac. The main part of operating systems are called kernels, and generally kernels are written in C. So Linux kernel used to contain some VLAs in the old days, but within time they have actually removed and updated those code, refactored them, and now Linux kernel claims to be VLA free. So VLAs are a special problem for operating system if they are introduced inside operating system, because they are like stored in a really tightly packed space, and wherever each thing is placed actually matters. So even in case of operating system, people go on while writing the code off and manually put inside a specific location of the memory specific things, so that things can be run properly for the operating system. So these kind of things are a special problem. So in case of C, I will let you use variable length arrays definitely if you need. But remember one thing, when you grow up and whenever you're working, in other cases, if you ever write a C program, try to avoid VLAs. Those are bad things. But like for labs or classes, VLAs are fine.
Sir, I have a question.
Yes, go on.
Sir, in a practical scenario where I don't know what the user might want, so he might want 10 values, 100 values. So how should I declare the array then? How many values should I give it?
So like if you do not want to use dynamic memory allocation, first of all, do you know about the upper bound? The first question comes, do you want an upper bound? Do you know an upper bound? If in your scenario, you know that the user will never enter a value more than 100, or what you can do, you make sure that your program will not require value more than 100. And if user enters something more than 100, you can take a if check, like if value is greater than 100, ask the user to enter the value again and tell him in her that you enter a value less than 100. You can do that one. If you know the size, 100, 1000, whatever it is, you can know that one. However, if you really do not know and you want to allocate in runtime, you need to use something called dynamic memory allocation, which I will teach you later, but it will look something like this. Like this allocates n+1 memory, that will kind of look like this one. This is now not being allocated in stack, rather it is being allocated in the heap. We're doing every other operation normally. This one creates the memory in the runtime. You do not need to remember this right now. I will teach it to you. I explain to you how it works later on whenever we discuss about dynamic memory allocation. So these things are called dynamic memory allocation. This is a pointer. This is a and I should free the memory. In these cases, you need to manage the memory yourself. That I'm allocating it, I'm deallocating it. So all those things, I'll teach them later. But this is what you can do. This will never cause a problem. This is the proper way, unless you basically exceed your RAM. But what is difficult in case of normal teachers. So this is the proper way. Okay. So any more question from this topic? Okay. If not, I've already shown you this one. It is example. Like take the number from the user, then scan those many numbers, store them in a tightly bound array, and then show the universe order. So that's all for today's class, and up to whatever I have taught is included in your mid syllabus. No more. Is there any other question from the topic of array? Okay. If there is no question, let's talk about the mid question. In the mid, there will be 3 questions. All of them are mandatory. That's the rule of IoT for online exams. I can do nothing about that one. So all the 3 questions will be mandatory. And then in each of the question, there may be like 3 more sub questions. I do not write a lot of writing, like writing comprehensions and things like that. So the questions will tell you, like, even if you like need to give some kind of description, the question will give you the limit that how much you need to describe. And I don't like description that much as well. So the questions will be really specific and to the point, and I want you people to answer to the point. And I believe that if you answer to the point, it will never require you like 1.5 hours. You can finish it quite early, the whole exam. Fahim, yes? Fine, Abrar? Fine, Abrar, you have raised your hand. You want to say something? Maybe he is having a mic issue or he mistakenly raised his hand. Anyways, so you need to answer all three of them. So go through the topics properly, read the slides, read the book if you think you need it, read the document that I have provided for the basic types, read those, and inshallah your exam will be great. Okay. So any more question about your mid-exam? Because I think you have got the like routine of the exam and the time of my exam as well. So when is my exam? Anyone? Like, who can look up and tell me?
Yes, sir.
So it's on the 27th of August.
Okay, so on 27th, like Friday. Okay.
Me also, sir. I missed your exam.
Yes?
I'm Shreya Nura.
Yes, Nora, you want to say something?
Yeah, I missed your exam.
Sorry, you?
Sir, maybe she wants to tell you that she missed your exam.
Okay. So if you miss your quiz, that's not a problem because in case of like quiz and assignments, there are more options. Like generally at least 4 quizzes or assignments are taken, and from those, the best 3 are counted. So if you miss one, that's not a problem. Do well in the rest of the quizzes or exams, and those marks will be counted for you. Okay.
Okay, sir. Thank you very much.
Sorry. Sorry, you have any more question?
No, sir.
Okay. So don't worry about like quizzes or assignments that much. Okay. From the next time, whenever like it's time for like a quiz or like exam, attend those, and inshallah will not cause you problem. Okay. So that's all. That's all I have to say about mid-exam. Read the topics properly, and yes, again, whatever topic Bhaktiar sir taught before me, those are also included. So remember that part. So any more question? Yes, Sakif.
Should we expect big questions like the ones in the lab for coding, sir?
So what do you think? Should I give questions like that in the mid-exam? What do you say?
No, sir, it will be difficult.
Okay, so like I have the lab, and then after the lab, there will definitely be lab vivas where we will like talk face to face. I have those places to evaluate you with those kind of questions. So why would I give it in like mid or final exam, right?
So then, sir, exercises from the books will do, sir.
If you want to exercise, the questions will be a bit different. Okay, the nature of the question might be different. One more thing, you encounter something called like COPO along with the marks of the question. For now, you can ignore those. Arsalan raised his hand, and then I think he might have got disconnected. He wanted to say something. I don't know. Okay, so along with the marks of the question, you will see something like COPO. Those are called course outcomes, program outcomes. For now, you do not need to be bothered about those. If you want an explanation about those things, I'll explain those to you later. But like those have things to do with the formatting of the courses. You will encounter them like in every question, like all the subjects. So don't worry about those. But the question will contain marks and something like COPO with a value with them. So focus on the marks, like if you want to evaluate like how much you should write for a question. So that's all. Do not write a lot.
Sir, do we have any lab exam in this meet?
No, generally the lab final is taken at the very end. Okay. Lab exams are not taken in mid, they like take place at the very end. And there might not even be any lab exam. It might be considered directly from the continuous evaluation. Or I might give you a simple lab project as well. So it depends on the scenario afterwards. Okay, based on a lot of things. Or I might make it a part of the Viva as well. Like during Viva, I can evaluate you separately. One for like a part of the Viva for the theory and a part of the Viva for the lab as well. Okay. Any more question? Arsalan, you wanted to ask something? Yes.
Sir, the next semester will also be on means online will be conducting online like this or physically maybe
Arsenal,
affected.
okay, so this decision is actually not up to IUT, rather it is up to the government of Bangladesh.
Yes,
So
sir.
if the government says that the educational institutions will be opened, they have like done the vaccination or other things, like if the government takes the decision, then IUT will open. Like maybe IUT authority will also do some research on those things and do what is best. I cannot tell you anything about this one. Only Allah knows best.
Sir, actually, I'm very worrying about because, sir, the programming is a such type of subject that is not possible when you are not working on it in a lab or mean physical classes is effective than that of online.
Yes,
You can
yes,
understand.
it is true that physical classes are far better, a lot better, like especially in case of labs for all of you.
Yes.
However, like there's no alternative, right? Because like all the things have been shut for like almost 2 years right now. So
yes,
either you progress or you stay far behind. Like 2 years is a huge amount of time. So the authority took the decision what is thought to be best by doing researches and things like that. So we can just only like hope and pray for the best. That the situation will be like will recover quickly, and like there will be no more COVID problem, and inshallah we can continue our physical classes as well, because online classes are hectic as well for all of you, for me. So
yes.
Any other question?
No, sir. And sir, one thing more, sir. In a paper, sir, the just the theory will be included or the lab we have taken.
The labs are based on theories, right?
Yes, sir.
So like if I ask you to solve a simple problem in theory, like in the exam, is it part of the lab or is it part of the theory? You can consider that the lab is part of the theory. Hence, if something is part of the lab, it is also part of the theory. Okay. So, but there will not be complex problems like the lab one in theory problem. And I will also not check the code strictly. However, do not go on and write wrong syntaxes, or like if you miss a semicolon in like maybe theoretical exam while writing, I will understand that okay, you were writing and you have missed semicolon in one place. That's not a problem at all. However, if you write wrong syntaxes, like if you even do not know how to write include stdio.h, printf function, scanf function, if you write those things completely wrong, unfortunately, I cannot give you marks. You need to remember those things. Those things should be proper. Missing a semicolon, those things, those are not a problem. But do not go on and intentionally miss a lot of semicolons. Do not make like C++ Python without semicolon. Okay, in that case,
got it, sir. Much means there will be a little extension given to us.
Yes, because whenever you're writing code on the paper, I will not expect you to write everything perfectly, but I will check your logic. Whatever you're doing is whether it's proper or not.
Okay, sir. Thank you. That's a lot for us.
If anyone else does not have any question, like I will take attendance before the meet for one last time, since a lot of you are not present. I knew that Hadaroni was present, but he got disconnected or he might have left. So I'll take attendance again, the same rule. Tamim, you're here, right?
Yes, sir.
Mustafshir, you want to say something?
No, sir. I'm taking leave.
Okay, just like give like a stay for 3 or 4 minutes. Just give the present and then you can leave. Okay. So I'll take the attendance. If you have any mic issue or something, write in the chat. Tamim will later add to that one. Abu Hana Shadid. Ari Rashid Khan Sifat.
Present, sir.
Abu Zaid Mohammad Ridwan Hussain.
Present, sir.
Mohammad Arafat Hussain Onjar. Yes, sir. Tawfiq Tawzar Dipto.
Present, sir.
Asif Abrar.
Present, sir.
Asif Mahmoud Fahim.
Yes, sir.
Karin Tasnim Ridhi. Karin Tasnim Ridhi. Fahim Abrar. Fahim Abrar. Fahim Abrar was. Yeah, you were present. Chaudhry Blossom Ibn Razak.
Present, sir.
Abdel Fayaz.
Present, sir.
Rabib Muntasir.
Present, sir.
Muhammad Ehsanul Haq.
Present, sir.
Mohammad Tanvir Chaudhary.
Present, sir.
Aryan Bashir.
Present, sir.
Iftikhar Zaman Ifti.
Present, sir.
Mohammad Naim Mubashir Monim.
Present, sir.
Labiba Nawar.
Present, sir.
Adi Samin Yasser Alam.
Present, sir.
Yes.
Sir, 108 was present. My mic was not working.
Yeah, I have given you present. Don't worry. Like, if you are having problem, write in the chat. Later on, I'll again ask the name of those who are absent, and that will be correct then. So don't worry. Okay.
Sir, 19 is present.
Yeah, Kazi Samin Yasser Alam. You had dengue, right? Have you recovered? Or have?
Yes. Sir, I'm present, sir.
Yes.
No, I don't have dengue, sir.
In the last class, you said that you had dengue, right?
No, sir, not me.
Oh, sorry. Yeah, 19. That's 20. Kawaza Ismail Marian. Ismail? Is he here?
No, sir. He just told me that to
Okay.
tell you that he is still in.
Still suffering from. Okay, it's fine. Okay. Sakif Kaiser.
Present, sir.
Radib bin Kabir.
Present, sir.
Yusuf Ibn Kamal Niloy.
Present, sir.
Miftaul Alam Siam. Miftaul Alam Siam. Mehdi Ahmed.
Present, sir.
Abdullah. Muhtabshir Ibn Ami.
Present, sir.
Muhtasimul Doha. Muhtasimul Doha. Okay, you're there. Maruf Ahmed.
Present, sir.
Samnun Asfar.
Present, sir.
Amifta Zaman Odhi.
Present, sir.
Majabin Tabassum.
Present, sir.
Mohammad Tamim Sarkar, you are there. Sadia Sultana.
Present, sir.
Fatma Nahian. Merin Tazin. Merin Tazin. Sadiq Salman.
Present, sir.
Muhtashim Kamal Dihan.
Present, sir.
Muhammad Zannatul Samaruk.
Present, sir.
Mushfiqur Rahman.
Present, sir.
Saima Situl Muna.
Sir, she is sick. She has gone to hospital.
What happened?
She has fever as well.
She has fever as well. She is thinking it might be dengue or something. That's why she has gone to hospital.
Okay. Sadid Hussain.
Yes, sir.
9F Siddiqui.
Present, sir.
Tanvir Hossain Dihan.
Present, sir.
Amir Sharvin Tivana.
Present, sir.
Shoaib bin Hassan. Shoaib bin Hassan. Arif Safwan Haq.
Present, sir.
Afan Saqib.
Present, sir.
Sayan Ilham.
Present, sir.
Tamim Ahmed.
Present, sir.
Anvir Ahmed Tanmoy.
Present, sir.
Sabir Alam Saad. Sabir Alam Saad. Tanvir Hassan Ananto.
Present, sir.
Munzer Mahmood.
Present, sir.
Amina. Amina.
Present, sir.
Wasa Lutufi Sebania.
Present, sir.
Okay, yeah, I have seen you. That's right. Arsalan Waqif Shah, you're here. Idris Farash. Idris Farash. He was also here. Yeah. He's here. Penda. Penda, I think Penda did it. Abdul Halim Hadarani, he was here. Alam Alzin, he was also here. Yeah. Ibrahim Muhammad, Ibrahim Ahmed, Ibrahim Ahmed, Ibrahim Muhammad.
Present, sir.
Sorry? Yeah.
I am
Seven,
again
yeah.
is present.
Yeah. Alzin and Sevani, yeah, I have given you present. Don't worry. And Suraya Nora, you're also present. So
Present, sir.
I'll call those who are absent once again. Khawadesh Mamarian. Okay, he had dengue. Miftaul Alam Siam. Merin Tazin. Then Simon Situl Muna has fever. Shoaib bin Hassan.
Present, sir. He's present.
Okay. Sabir Alam Saad, he is absent. Penda Kolebeli. Thank you, everyone. That's all before the meet. Best of luck in all of your exams. Inshallah, they'll be great. Okay. We can, like, all of you can leave. Thank you.
Thank you, sir. Assalamu alaikum.
Thank you, sir.
Assalamu alaikum, sir.